Ryan is here setting up for the much anticipated lightning talks. If you have a lightning talk accepted for today, you might want to make your way towards the front because it's going to be going pretty quickly.
Thank you. So, this isn't always exciting. Oh, wait. You actually don't need to all swarm me right now. I appreciate the enthusiasm. But are we, so the way we're going to do it is I'm going to announce the first person to come up. It's Karma. And then I will announce the next person on deck. So you'll have the opportunity during the presentation to get to the talk. And that will, of course, be with the quasi-official scroll that I have here. So on deck, after Karma, will be GuyTech BCI. So you should start making your way up. But everyone else can relax. And for those of you who have not done a lightning talk before, there is a timer here. I'm not going to give you the nice 5-minute warnings or whatever that Denise did. Sorry, not Denise, Deanna. But there is a giant clock staring you in the face. It's very hard to miss. I will sit down there and point if you need it, but it's hard to miss. So it's just it will show you minutes, and then don't worry, once it gets under 1 minute, it will click down into seconds, so you'll know. And for everyone else, those of you who are familiar know that we do really respect the 3-minute timeline, but we do so quite politely. When we hit the 3-minute timeline, or the 3-minute time limit, I'm going to stand up, and we're all going to clap the presenter off the stage. So I'll lead the presentations, and then we'll all just clap them off the stage. And for those of you who might be tempted to overstay your welcome, please keep in mind that I have more coffee this morning than I have had in the last 4 weeks. All right, let's get going with Karma. Are we good to present? Yes, you use those. I am keeping this microphone.
You can.
Presentation, please. There we go. Wonderful.
Brilliant. Thank you. Good afternoon. My name's Aaron Griffiths. I'm from the University of Manchester. I'm here to talk about Karma, nuclear inspection robot. This is just one of our fancy buildings up in the north of England, and these are the people that are associated with the group. The presentation is going to be quick, short, sharp and sweet, so I'm just going to talk about challenges in the nuclear industry, Karma 1, Karma 2 and our ROS contributions. These are just a list of all our partners, and we're up at the top there, University of Manchester, and you can see we have some international partners as well. So if I get straight onto it, what is a challenge in the nuclear environment? So in the north of England, there is a place called Sellafield. If you've heard of it, it's the bottom corner picture there. It's a large industrial site, about 700 acres. It has over 2,000 buildings. Many of these buildings are actually active in nuclear. You can see that the various challenges they have on site is they have to cover this ground. There's all this floor space they have to cover. So at the moment, they're using human operators to do this, and they're scanning manually to do this. So we thought, as many of you would think, oh, why don't we build a robot? So we decided to build a robot. And as you can see, it's based on the Turtlebot 2. We took some industrial standard radiometric tools and we integrated it into the ROS framework. We attached the LiDAR on top, and then we started to do some basic radiometric mapping in two-dimensional space. And Karma 1 was pretty much a success. It developed maps for the people in two-dimensional environments. As you can see, each of the green points is what the dose rate expected there, and the red is where it found radiation. This is such a success that we actually deployed it onto the Sellafield site, which they were very pleased about. So they gave us a bit more money, and we've now developed Karma 2 using a ClearPath Jackal, so shout out to ClearPath. We use better sensors, Hakuyos, so on and so forth. Just a quick video of Karma, which should start. Sorry. So this is just a very quick video, just to show you in action. It's not groundbreaking in any sort of way. It just does routine slam, and then just goes around in various space to produce a two-dimensional map. So this is in our site up in Cumbria, and what they actually like about it is that it produces these individual points on a two-dimensional space. At the moment, the nuclear industry hand draws most of their radiometric maps of the given facilities. So the beauty of this system is that the robot produces all this information in much more accuracy for them, and they can use the data set to then in their surveys and so on. Sorry, I've run out of time.
3 minutes on the dot. Thank you very much. All right. On the up right now, we have GuyTech, and number 3 is ROSBAG for ROS2. And in case you're wondering for tomorrow, no, putting ClearPath in your product or ClearPath products in your video does not give you any more likelihood of being selected. Here we go. Come on.
Hi everyone, my name is Ali bin Wahid, and I'm a project engineer at GuyTech Robotics. Today I will introduce you to GuyTech BCI, which is a ROS-based comprehensive hardware and software platform for building interesting brain-robot interfacing applications. So we have ROS and neuroscience experts in our team who worked very hard to come up with this product. So I will briefly explain how brain-computer interface works. Our brain has billions of neurons which carries information in form of electrical charges. These electrical activity produces electrical potential on scalp, which are very minute in magnitude but can be measured using metallic electrodes. According to research, this electrical activity correlates with underlying brain activity. So researchers tried to extract features out of these time series signals, and EEG-based brain-computer interfacing has number of interesting and potential applications in rehabilitation robotics, neuromarketing, self-driving cars, and entertainment and security. So this is the comprehensive and high-quality software and hardware platform that we have developed. So it has a 10-channel wireless non-invasive EEG headset. It has dry electrodes along with set of very useful ROS packages and ROS-based software and tools for helping researchers, especially during early phase of BC application development. So there are three, as you can see, there are three main ROS packages that we have developed. And this is an open source contribution. You can see the source code at this GitHub link. So this is the EEG device, and it has dry spring-loaded electrodes. It can, for hairy part, it can get the results, get the signals out of it. And foam electrodes are for bare skin on the forehead. So a thorough research and development effort has been done in order to come up with good quality signal acquisition and processing at hardware level. So I will be quick. So this is the bring up package. It can bring all the real-time data from EEG device, and there are a few other details that you can see on the our GitHub page. So I will be quick to show the demo video. Can it be played? So this is where I am trying to control the turtle bot using brain signals.
This is my serious face. All right. Up right now, we have ROSBAG for ROS2. You're doing a slide-in video. Good luck with that. And on deck, we have mixed real-time criticality with ROS2. Talk 3 video. Oh. Ooh. I think I just spoiled your talk.
Don't worry. It'll be fine.
Yeah. All right, let's rock and roll. Thank you.
Yeah, anyway, we'll see about the video. So, will it appear? Apparently not. Can I?
just leave it continuing to display the output. Don't worry about dropping back to the other screen.
But that wasn't even the one that I gave her.
Please stand by. Everything broke.
Yes.
That button.
It doesn't have any. You can't click any button. Whole PowerPoint crashed.
I would like to request OSRF IT to report to the front, please. I think that's you, Brian. I don't know. What just happened?
Yeah.
Oh, PowerPoint crashed. Hey, Microsoft. We would like to thank you for your support for ROS. We'd like to thank you for your support for ROS2 and now request a, I don't know if this is a pull request you can help with? Yeah, okay, there we go. Let's enable external content. What's the worst that could happen?
Okay, this looks better.
All right, are we? Doo, doo, doo. No, it's okay. There we go. Okay.
Yeah, there we go.
Thank you.
Thank you. Thanks, everyone. So my name is Martin Edel, and I'm from the TNG Technology Consulting. My colleague presented this morning our work on porting Arbis, and now having finished that, we are still being paid by Bosch to now work on ROS-back. So I wanted to give you a quick overview because I think this is very much an anticipated feature for us too. If you want to get involved or see whether your use case will be covered, there's a design document that you can have a look at. So in principle, there was a video. I don't know whether this will probably not work. This is why I had it also. So let's first have a quick look at what the status is. I will show you a video where this is actually working. So we can do recording and playing, and we are storing into an SQLite 3 backend. So no performance tests have been done, except in advance where we check that SQLite 3 should also have very performant use cases, allow very performant use cases. The SQLite 3 backend is a plugin, so if you're really unsure that this will work for you, you can already start implementing your own plugin. The code is there. Also, if you want to help, we can use some help implementing some plugin to read old ROS-back ones from ROS1, because this would be very useful. So let's see whether I can get the video to No, probably not. So, because for some reason. Anyway, as I said, yes, exactly, there we are. So as you can see, we have some fabricated data. It's obviously not real data. And now we just press ROS-back record, and it will do something. Storage will be set up. It will actually use the serialized data from the middleware format and store this directly. This is much faster, but it's also not portable to all formats, right? So there will be some conversion plugins, but this has not been implemented yet. Now we stopped it, and we're going to play it back. So there we go, ROS-back play. Well, test.back. As I said, this is SQLite 3 backend, and there we go. The timing behavior should be accurate, except if you're trying to ROS-back your whole car setup. I guess the performance will not be as good there. But the architecture should, in principle, allow for this. So as I said, maybe this is already interesting for you. Maybe you want to play around, or even help us, or even start to develop your own storage plugins. All right, that's it.
Thank you. I do like how you just casually were running ROS on Windows to do all that without even mentioning it. C prompt for ROS-back. All right, so we've got Mixed real-time criticality up now, and next up we have Geeta. All right, what am I even going to? Yeah.
Hello, I'm Morel from Bosch Research, and it's my pleasure to present our work on a callback group level executor to support mixed real-time critical applications with ROS2. ROS2 basically uses the same computational model as ROS1 with nodes, with callbacks, which are triggered by messages, by timers, and these invocations are processed sequentially by a spin thread. For this purpose, ROS2 introduced the notion of an executor on the RCL-CPP layer, and each process has one instance of this executor that works as a spin thread on these invocations. And as you learned in the morning, it's also possible to put multiple nodes in one process in which one executor will serve those nodes together. Now, we thought about applications where we have different real-time requirements in the same node. For example, an emergency stop callback that should be processed in any case, even if there are other invocations before. And our approach is to create multiple executor instances in the same process and to configure them the normal operating scheduling mechanisms like priorities, core pinning, or batches. And for this purpose, we had to refine the executor API to work on the level of callback groups instead of whole nodes, and also to use more refined waiting sets on DDS where the actual queues are managed. In addition, we allow for annotations to the callback groups to specify real-time requirements to do this mapping automatically in the future. We did a fork of ROS RCL-CPP and created a new branch where I was given on the slide, so you can download it and try it out yourself. Also, we did some very first experiments. We created a simple application with 2 nodes and 2 paths with different criticality, just sending ping-pong messages around and burning CPU cycles in the Pong node. And our first test validate that this whole stack is working as expected with regard to real-time requirements. That's also a fork of the ROS2 examples repo, again a branch meta executor that you can try out. Feedback is warmly welcome, try it out, contact us, and many thanks to William for helping us to dig into this whole stack for Carsten and my colleague Dakstina. Thank you.
2 minutes and 15 seconds. Thank you for that, despite having a title that took up 10% of your talk time. All right, up we have right now is Geeta, and up on deck is ROSCon JP. You want slides or video first?
Just a slide.
You don't think the video is good? Okay, perfect.
Hola, Madrid. Hi. I am Carlos Esmat, and I lead the robotics team at Piaggio Fast Forward. Piaggio Fast Forward is a member of the Piaggio group that you might know from brands like the Vespa, Aprilia, Moto Guzzi, all those light transportation vehicles. So at Piaggio Fast Forward, we're based in Boston, and we are making Geeta. So Geeta is it's a word in Italian that means short trip, and it's a robot that follows you around and carries your things. So when I joined the company is very young. When I joined it, we didn't have any robot or only a few prototypes. And after 9 months, we were able to finalize a robot that could accomplish all these things and do that in an uninstructor environment. So this is what it looks like. Being an Italian company, we are very focused in design and making sure that things are not only functional, but that they look pretty good. So that's Geeta. It follows you around. You open it up, you put your stuff inside, and then it carries it. The main challenge of this is not to make a robot that does this, because thanks to ROS and thanks to all these open tools, we were able to put this together pretty quick. However, the challenge is to make this as an affordable technology. And so that's So that's what we've been working on, basically bringing this and making it into a consumer product. And that's also something that we want to carry ROS with us into that jump as well. So there were many challenges, and happy the GIF worked. Yeah, so I mean, we had to build a team, and then we had to basically architect this entire system, and it took a lot of work. But yeah, I just wanted to thank everyone who made ROS possible, and also just saying that we are also hiring. And we're growing a lot, and it's a lot of fun to address all these challenges. So, thank you.
Thank you very much. For the record, I'd like this to be start of just endless robot GIFs. And other Lightning Talk presenters, you can probably assume that everyone knows that you're hiring, so it'll save you some time. You don't need to say it. Just assume that.
We can't.
Sure you can. All right, we've got ROSCon JP up here, and next we have Robot Recorder. Take it away.
Hi, I'm Jeffrey Biggs. This is Yutaka Kondo. We're here to talk about ROSCon JP. This was a Japanese ROSCon, the first official local ROSCon, co-sponsored by the Open Source Robotics Foundation. And we held it 2 weeks ago in Tokyo, in Japan. And we had quite a successful conference. We sold out, got 200 people along, had a great day. Had some wonderful talks in our program. First, we had a couple of invited speakers. Brian came along, gave us a great talk about ROS and ROS2. And Nicholas Yeo from ROS Industrial Asia Pacific came along and told everyone there about why they should all be joining ROS Industrial Asia Pacific. We also had 26 presentations submitted, which we reviewed and accepted 14 of them. They're all great. Had a very interesting program. Things like Ibo came along to say hi. Unfortunately, he won't be coming along tomorrow, apparently. He got stuck in customs. We also had 13 lightning talks, which was great. We should thank our sponsors, particularly our platinum sponsor, Sony. Without our sponsors, this conference would not have happened. We had a lot of gold sponsors, some names you'll see here today as well. Whoopsies. And silver sponsors and so on as well. And of course, Open Robotics, who gave us a lot of support over the past year. Lots of emails going backwards and forwards saying, how do we do this? What did you do to fix this problem? And so on and so forth. And of course, no conference goes well without its small army of volunteers helping to make things work out, keeping the registration desk going and so on. Now I'd like to tell you about the 3 stages of ROSCon, which is the biggest lesson I learned from the day. When you organize a ROSCon, you go through 3 stages. First is anticipation. So you've got everything set up, the chairs all laid out, the exhibitors have come along, you've got your staff, and you're wondering, will anyone actually turn up? And then everyone does turn up, and you get a whole day of continuous mild panic as you're trying to fix problems. But it's all worth it in the end, because the 3rd stage of ROSCon is the drinking. So yeah, it's all good. So some quick stats. We had just 14.3% of our participants were students. The rest were all in commercial in some way. Half of those, over half actually, were engineers working on ROS. When we took our survey, everyone said we did great. They loved our conference. You know, we had wonderful presentation quality, and apparently we were spot on with the presentation links. So hopefully we'll get that right this time too. And when we asked them, will you participate next time? Out of 105 people who responded to the survey, 2 people said no. We're not really sure why. One did give a very long list of complaints, like you didn't give us desks or place to charge our laptops. But oh well. If you're interested, the videos and slides will be available at the website you see here, sponsored by Renesas, who's also here today. We're looking at a way of trying to get some subtitles up, because it is in Japanese, apart from Brian and Nicholas's talks, but we'll see. And since it's such a great success, we're going to be doing it again next year. So we aren't hiring, but we do want sponsors. So, thank you.
Excellent, thank you. So that the IBO, is it vaccinations or what's? Okay. All right, up behind me is Robot Recorder. Yep. And ROS and Retail Robotics is on deck.
Okay. Hola everyone. So I want to present a new tool that I've developed. It's a rather small tool.
And to my person, I'm Jonathan. I'm from the Research Institute Fraunhofer IPA. And the tool that I'm presenting is called Robot Recorder. And the basic idea is that an animation is worth 1,000 lines of markdown. So what is the goal of this robot recorder? So it does record the ROS application, and then you can use that recorded animation to replay it in your 3D in your web browser, and that is a 3D animation. And what are the reasons to do so? So one reason would be to get an eye catcher for your application so that everyone can see really quickly what it's about. Another reason is if you integrate it in your continuous integration pipeline, you can use it to inspect failed CI tests. And the last reason could be that you want to do some visual benchmarking of, say, different parameters. And so what does it actually record? On the one hand side, it records external motions from transforms, so you all know the topic TF. And on the other hand, it records internal motions from the joint states. And so how do you actually use this tool? So you can control the recorder with ROS services. Therefore, you can automate it, and as I said, use it, for example, in your testing. But on the other hand, it's also mapped to some Arbis plugin, so it's very easy to use. And the recorded data uses keyframes, so only stuff is recorded if it actually changes. This reduces the data storage, and in the end, it is exported as a JSON file. Once you have this recorded animation, you can use it in what I call animation viewer. So this is a wrapper for the URDF loader, and it includes the animation, and it's really cool. You can host it on your GitHub pages, and you can cross-load meshes, for example, from other GitHub repositories. Therefore, it's really lightweight, and you have some 3D animation of your application. Also, with just one click, you can convert the application to a GIF. This makes it easier to include it in, for example, in your README. That's about the tool, and of course, it's available on GitHub. You can find it with the name robot_recorder. Thank you for your time.
I must compliment Fraunhofer on your efficiency. I only asked for the GIFs two presentations ago. Okay, we've got ROS and retail robots up here, and on deck, service robotics modules. Video first. Rename the video first.
Yeah. Perfect. Hello, everyone. I'm Aaron Blaisdell. I run the robotics team at Bossa Nova, and we do retail robotics. So I want to kind of tell you about what retail robots can do. So retail stores actually know surprisingly little about their shelves and what's going on in their stores day to day, because their customers are constantly modifying those shelves and doing really bad things. Like, have you ever seen like a package of meat on a random shelf? Yeah, that's not good for them. So just not knowing how much of each product they have, repeat would have been nice. How much they have of each item on their shelf at any given time costs them worldwide costs robot. Sorry, keep talking. Yeah. So worldwide costs retailers $1.1 trillion annually, and so what we at Bossa Nova help them understand is what's missing from those shelves and what's in the wrong place, among various other things. And so let's switch over here. So what Bossa Nova actually helps them understand is that state and how they can manipulate that. Oh, we're doing great. Okay, who needs slides? And so the Bossa Nova focus is on production grade real-world robotics in an unconstrained environment. And so we drive around the stores, and we have lots of these kind of things to deal with. Currently, we're delivering in 50 Walmarts every day, multiple times a day, to get them the information they need to support their restocking processes and those kind of things. And right now, if the slide was up, it would be showing you that we have 3 main development offices in Pittsburgh, Mountain View, San Francisco, and we also have sales offices in the US and UK, so if you want to go and talk to them today, feel free to go by. And feel free to come by in our, to see us at the coffee and ask us questions about how we actually do all of this. So thanks for listening.
Thank you very much. Oh, hey, the key was enter. All right. Up behind me is Service Robotics Modules by Pils. And next up is, I never actually knew how to pronounce this, SMATch, SCXML Interpreter. Okay. And there we should go.
Hello, my name is Joachim Schleicher from Pils, and I'll talk about service robotic modules from Pils. It's a small or medium-sized company from Germany offering safe automation, product and services, and Pils launched its robot manipulator PRBT. It's a 6-axis robot this year and has 6 kilograms of payload, 24 volts power supply, which makes it perfectly suited for mobile applications. And it has a CanOpen interface that we use to command it directly from ROS. So a joint trajectory, having individual joint positions over time, is directly commanded over the CanOpen interface to the individual drives. So you can use ROS as a robot controller. You do not have a vendor-specific robot controller if you use this manipulator, but can use the CanOpen interface directly. Therefore, in industry, you probably often have linear and point-to-point movements where you want to have reliable, reproducible commands with trapezoidal velocity profiles. And with support from ros-i, we developed a package called Pils Trajectory Generation, integrated with the MoveIt and the ROS control stack to generate joint trajectories for a given linear command. Check out the code, it's open source at the Pils Robots or Pils Industrial Motion package. What's next? We look into integrating more Pils products like the laser scanner or like our safety mat into ROS to get those data into a unified environment model. And we see large potential into using ROS as a platform for ROS. And yeah, just meet us. We welcome feedback. Try it out. Let us know what you think about it. And we are over in the coffee break at the ROS Industrial booth where you can see the Pils manipulator in action. See you there.
Thank you very much. I'd like to issue you a challenge to now to give an overview of ISO 12100 in 3 minutes or less. All right, we've got SMATch up behind me, and then the Zell network. I'm sure you'll tell me how to pronounce it on deck.
So, hello everyone, I'm Ludovic Delval, so I'm a colleague from Jonathan from before, also working at Fraunhofer IPA, and I'm going to present you a 6XML interpreter, which is an extension of the SMATch frameworks. So, if you're in the ROS community from sometimes, you probably have already encountered SMATch, which is a great framework to create state machine, but it's difficult to maintain, to scale, with as you get more states inside your state machines. And also, the problem is everything is Python, so it's difficult to non-Python user to actually use the simplicity of SMATch. So, in order to going forward, I've developed a S6ML interpreter. So, S6ML is a standard used by the World Wide Web consortium. and making the conversion between this SXML standard to Smash directly automated. So actually you can use a S6ML editor, even a GUI assisted editor like the one that I present here is from Qt Creator, and create your your Smash state machine directly from there. So you still have to create the Smash states, but once your Smash states are created, you can assemble them and create the state machine and run it directly from the S6ML standard. You can also use some of the S6ML tools like data model, on entry and on exit script and conditions directly in the S6ML, and it will be interpreted in Smash. So this S6ML editor and interpreter is already used. So it has been presented last year a bit around for Airbus autonomous crew driving machines. So it's a new version which is completely reworked and very focused on Smash. It has been also used in the ROS Industrial Pick and Place demonstrator showed at the last ROS Industrial conferences. And it's currently being tested and used in its last version as a scalable, in the European funded project Scalable 4.0. So where do you find it? So it's on GitHub, and if you want also a Qt Smash viewer, because the Qt Smash viewer is a bit unstable, so I've been working on the reworking introspection, and Qt Smash viewer is available there. Thank you.
By unstable, do you mean it's not a bug, it's a feature?
Kind of.
Okay. All right, we got the Zell network, and on deck, feeling by seeing, ros-i robot vision.
Okay. Hi, my name is Kane. I'm a permanent engineer at Robotics Corporation. Now I will introduce cell network projects which aim to model hardware ecosystem using ROS2. Main purpose of cell network is to make practical system with microcontroller using ROS2. This is a firmware architecture we are designing. We are applying this architecture to support Turbo 3 ROS2. Therefore, it can be also used on Arduino IDE. And we used this architecture to make a cell network both as prototype. From the left, COM cell, power cell, and sensor cell. Each cell has an accessible memory area called control table. We used it to plug and play and transmit data. Currently, the dynamic cell protocol is applied for this communication, and other protocol will be applied, added in the future. And there is a GUI tool called the Cell Manager for access easily to control table. For using DDS, we are using micro RTPS developed by Iposhima on COM cell. There are three main features of cell network. First, using Cell Manager, you can set topic type and name of the sensor connected to sensor cell. Second, you can use each sensor information as lost topic by just plug or unplug. Third, hardware configuration is more convenient because date chaining is possible by dynamic cell protocol. There are plans for the future, but time is right. For more detail, please refer to development in our wiki or visit our booth. And we welcome users' contribution in any way. Thanks.
And you are hiring? Yes, no, maybe? Looks like yes. All right. You are now. Okay. So we've got feeling by seeing up now, and then HRIM on deck.
So hi everyone, I'm Rufan. I'm an electrical engineering student from the Technical University of Munich, and today I'm going to talk about a camera-based sensor for smart robots from ros-i Robot Vision, which is a spin-off from the Technical University of Munich. So ros-i mainly aims to improve the affordability of robot arms, but still maintaining a relatively high precision. And current intelligent arms, they rely on all kinds of electronic sensors, for example, joint encoders, force torque sensors, or haptic sensors. And this makes the system rather complex and also results in relatively high costs. So the key idea of ros-i is to use a camera-based sensing technology, which replaces the electronic sensors you need on a robot arm. And so you can build an entirely sensorless robot arm, which should reduce the entire costs. Yes, and the solution actually relies on three components. First is a camera, which looks onto the robot arm. And second is passive elements, for example, visual markers depicted here in green, and passive flexible elements like rubber foams. And also you, of course, need an image processing software, which searches for the components of the robot arm in the camera image. ros-i built like 3 prototypes. So on the left you can see a robot finger with 2 passive tactile sensors. Actually it's just a 3D printed part with 2 rubber foam bars. So and these rubber foam bars, they deform when getting in contact with an object, and so this deformation is sensed by the camera, and therefore you can calculate the forces. In the middle, you see this robot finger integrated into a gripper system, and on the right is a camera-controlled robot arm based on off-the-shelf hardware parts, and which is entirely sensorless. So except for the camera, you have no sensors on this robot. And as for the software part, everything is, of course, built in ROS and fully integrated into MoveIt. And for the last obligatory slide, ros-i is looking for partners, investors, and team members. And if you have any questions or are interested, feel free to contact us or visit the iROS booth, where we also will present the robot arm. Thank you.
Thank you very much. Next up, we have HRIM, or what have you. And on deck, we have ROS2 on WebOS. Take it away.
Good afternoon, everybody. My name is Irati Zamayoa. I'm industrial design engineer at Ros Robotics. As some of you already know, our team is focused on robot modularity. And one of the points in modularity is to solve the software incompatibility problem. So I would like to present you today a solution for this. Is HRIM, the hardware robot operating system. It's a common infrastructure based on ROS2. HRIM is an information model for robot components, and it's going to help us a lot to reduce the integration time. It allows us to unify all the software aspects inside the modules. So that's to say, HRIM standardized the topics, the messages, the parameters, and the actions of all kinds of robot components. For example, if you visit the Ros Robotics stand, you will see this robot. It's our hybrid robot, and it's built by manufacturers, different manufacturer components. By the way, we are open to partnership with everyone interested. Thanks to HRIM, each component can interact between each other in a same manner. we have seen that A-trim is innovation, that all the robot industry is strongly demanded. Actually, A-trim is supported by ros-i. But one of the most important points here is that A-trim is an open and collaborative project. It's an open source. There you have the GitHub address. You can enter, comment, collaborate with us, adopt it, and we will take your feedback. Also, for more information, you have there check our website. And if you have any question, just come talk to me. Thank you.
I was kind of hoping for another GIF. Okay, we have ROS2 on WebOS, and then on deck is the last one of the day. So I hope you know who you are, but if not, it's the autonomous simulator for Baidu.
Just restart it. Okay. Hi, everyone. My name is Brian Shin, and I'm with LG Electronics at our Silicon Valley lab office. So I'll be playing this video as I talk. I just wanted to quickly introduce you to Beanbird Robot. Beanbird Robot is a demonstration of ROS2 running on WebOS. WebOS is a Yocto-based embedded Linux distribution, and it's lightweight, so it's meant for cheaper embedded devices that are deployed, such as LG's smart TVs. So when you're actually deploying fleets of robots, you want to maximize performance while minimizing costs, and that sometimes means you don't really want a full desktop distribution like Ubuntu running on your fleet. WebOS allows you to have full ROS2 as well as nice-looking web applications that are easy to develop based on the Enact framework. And this also allows you to have really fully reproducible, deployable builds that are constant across like all your robots. So the Beanbird robot here that we show, it runs on a single Raspberry Pi board, and the features, as you can see, are sort of joystick control, perceiving and responding to its environment, obstacle and cliff avoidance, and things like this. And instead of starting with a full desktop Linux distribution, we start and take only the components into the OS that are needed. So only the ROS2 components that are needed, only the kernel modules that are needed. In this case, it's things like joystick drivers, support for touchscreen, support for I2C and GPIO. And this allows you to kind of cut down on the footprint of your entire system image. So we built this on top of the community that's supporting the Meta ROS. If you're at all interested in the sort of open embedded community, please check us out on GitHub under the LG SVL organization. If you're at all interested in the open embedded sort of side of ROS2, we'd love to talk. We're also going to have a booth at IROS, so please come check us out there as well. Yeah, thanks.
Did you have to make the eyes turn red? Last up, autonomous simulator for Baidu Apollo. Oop, and there we
go. Let's restart it. My name is Dmitry, and I work in LG Silicon Valley Lab as well. And my video is exactly 3 minutes, so by the end of the video, I'll just jump off the stage. What you can see right now is a simulator which we built with a Unity 3D, and we integrated it with ROS, so you can run autonomous system like Baidu, Apollo, or AutoWare with the simulator. We mainly look at integration with autonomous vehicle, and we have multiple things in there. You can basically see that we have multiple views from the cameras. We have integration with LiDAR, with radar, with radar. We have also an ability to generate 3D maps from the simulator itself. So you just make the map, put it into the place where Apollo wants to find it, and it is possible to load it and just to run it there. So we aim to make it really easy to use for developers. So if you're playing around with AutoWare or with Apollo, you can find the simulator on the GitHub, and if you want more information, we can have a conversation on IROS next week. What you can see here is basically the simulator running with Apollo. It is able to follow the path. It is able to see the obstacles and also predict the motions of other vehicles. And it is also using virtual cameras to basically see the red lights. And we didn't actually do any changes in Apollo to make it run. So all changes are in the simulator itself. Yeah, and later you will be able to see that it's actually able to simulate kind of sophisticated environment where multiple vehicles are at the intersection, and yeah, you can see right now. And like from the right side, you can see how Apollo sees everything around. Yeah, that's mostly it. If you're interested, yeah, just let me know.
I saw some rolling stops and red light runs in there. Yeah. You are ready for San Francisco. Congratulations. All right, everyone. We are finished the lightning talk, so let's give all of our presenters a round of applause.